Welcome to CSC channel, Computative Science channel. Now we'll move for graph problems. See, here the velocity are taken in y-axis, time is taken in x-axis. Now the question from the graph problems. Maximum instantaneous velocity of the particle is around the point A, B, C and D. For this problem to solve, we have to analyze the graph. See, the maximum instantaneous velocity of the particle is around the point. Here the maximum instantaneous not there in A. So the answer A is not the answer. Then in the B, it increases the velocity, but it is not instantaneous. Means sudden increasing not. So option B is also wrong. Then come to the D option. Here the velocity somewhat constant will be there in the after the D point. So answer this is wrong. So the remaining answer is C, where we noticed instantaneous velocity has changed. Sudden changes we notice there. So the answer C is correct. Second graph problem. Which of the following is zero according to the given graph? Velocity, speed, displacement, acceleration. Here in this graph, a y-axis is taken as velocity, time is taken as x-axis. Here the graph given a parallel line to the time. Hence, the velocity, here the given velocity is a constant, it's same in all the time, but it never becomes zero. So, the answer velocity not. Then coming to the speed. Velocity and speed both are the same. Only the velocity is vector quantity, speed is a scalar quantity. Here the object moves with the velocity and hence the speed is not zero. The displacement. When the object is constant in the velocity, it changes its position. So the displacement is not at all zero here. Then coming to the last one, acceleration. Here the velocity is constant at all the times here. So the acceleration is not increasing or decreasing. That means rate of change of velocity does not occur. Hence the answer, the acceleration is zero here. Another graph problem. Which of the above graph is possible in practical? Means in a day-to-day practical, which graph is possible? Here A, B, C and D all are velocity and time graph. See, when you see this seems to be a tough and critical graph itself. Which of the following is possible? Means here in one time only two types of velocity we are saying this is impossible. And here also in a one particular time many types of the different velocities we are seeing. So this is also impossible in practical. Here also in particular time we find the two types of velocity here and here. So this is impossible. The possible is that of B graph, because in particular one type of velocity only can be seen. So the graph B is correct and it is possible in practical. Coming to the last graph problems. S is directly proportional to t square. That means distance is directly proportional to t square when a body is coming to the another graph problem. S is directly proportional to t square when a body is accelerated. Which of the graph represent correctly? Here the distance is taken in y-axis, time is taken in x-axis. So here the four type of graphs given. Which graph represents correctly. Here S and T uniformly distributed, means distance equally moved in equal interval of time. So this cannot be represented. This distance directly proportional to T square. It's not be possible. Here it is distance is decreasing in a time. So as the time increases, distance also increases. So this also wrong. Here the distance is same at all time, means S is equal to 0 here, means object is at rest. So this graph is wrong. This graph is correct because as the time increases, the distance also proportional to the time. So this is correct. Thank you for seeing my video of CSC channel. Next we are going to do the numerical problems on the motion. So if you like, please subscribe my channel, CSC channel, Competitive Science channel.